Okay, these are some problems from section 9.2, and this is number 13. And number 13, if you read in your book, it says, find the Taylor series generated by the given function, or by the function at the given point. And the function was going to be, in this case, was going to be f of x equals 1 over x plus 1 at x equals 2. So again, we just, so x equals 2, so we're going to, our center will be 2, so we're going to be dealing with x minus 2 rather than just x. And if I set up my Taylor polynomial, my general formula, this is going to be f of 2, x minus 2 to the 0, 0 over 0 factorial, f prime of 2, x minus 2 to the first over 1 factorial, f triple prime, or I'm sorry, f double prime, 2, and then x minus 2 squared over 2 factorial, etc. So this is the general formula for the Taylor. So what we had to do is we had to find the derivatives at 2. So if I take the derivative, this is just f of x. Okay, so f of 2 was just 1/3, and then if I take the derivative, this was actually negative 1 over x plus 1 squared. And I think I gave you kind of a general form on that, the way that works, so you could use that to generate these derivatives. So f of 2 was just negative 1 over 2 plus 1, which is 3 squared, which is negative 1/9. And then f double prime, if I take the derivative of this, that's going to end up being, remember the signs are reversed, and that's going to be 2 over x plus 1 cubed. So these kind of alternate, and then the tops become the factorials. This is 0 factorial, 1, 2 factorial, 3 factorial. That's the way it works out when you do these fractions. So f double prime of 2 is 2 over 3 to the third, or 2 over 27, and then again one more, f triple prime ends up being negative 6, x plus 1 to the fourth, and that's going to be, so f triple prime of 2, if I put 2 in here, that's going to be 6 over 2 plus 1, 3 to the fourth. And I found a general formula for actually the derivative. You can see the derivative is going to be alternating signs, and it looks like this is going to be, if I go from 0, this would be 0 factorial, 1 factorial, 2 factorial, 3 factorial. So you can see the numerators are going to be n factorial, and the denominators are just going to be 3, and if I start at n equals 0, which I did over here, n equals 0, this is just going to be 0 to the n plus 1. So there's the general form for the derivative. So I could actually put that in to my Taylors over here. But I generated it. So you can see how it generates. Okay, so this is my derivative, 1/3 minus 1/9, 2 over 27. I could have put negative 6 over 81. But I just did this many terms. I think I was running out of room. And then I put over here the general. So this was the general form for the derivative. And this was the rest of the Taylor's form. X minus 2 to the n over n factorial. Alright, so again, this was the general form for the derivative. Now notice what happens. The n factorials cancel. So I end up with negative 1 to the n, x minus 2 to the n, all over 3 to the n plus 1. And there's the general form for the Taylor polynomial. Okay. Alright, and then number 14. Here we go. F of x was e to the 1/2 x, and we're going to have this centered at 1. So again, here was my general form. I wrote my general Taylors over here. F of 1, x minus 1, 0, 0 factorial. F prime of 1, x minus 1 to the 1, 1 factorial. F double prime of 1, x minus 1 squared, 2 factorial, etc. So you can see the pattern there. So we need to find our derivatives. So the first, the function is actually e to the 1/2 x. So the first derivative is just, or this is actually the f of x, e to the 1/2 x, when n is 0. And then f prime is 1/2 e to the 1/2 x. Then f double prime 1/4 e to the 1/2 x. F triple prime 1/8 e to the 1/2 x. And then if I put 1 in here for x, I get e to the 1/2. 1/2 e to the 1/2, 1/4 e to the 1/2, 1/8 e to the 1/2. And I could kind of put these in powers of 2. This could be like I could call that 2 to the 0, 2 to the first, 2 to the second, 4, 2 to the third, 8, etc. And I can get a general form for the derivative now. It looks like it's just e to the 1/2 all over 2 to the n, if n is going from 0 to 3. So here's my Taylors that I wrote out. This was just going to be just e to the 1/2, e to the 1/2 over 2 times 1 factorial. There's the 1 factorial and there's the 2. 2 squared. So this was your derivative part here. This was e to the 1/2, 2 to the n. So you can see your derivative over here. And then again, I had the derivative e to the 1/2 over 2n, and this was the Taylor's part. This was the general form x minus 1 to the n over n factorial. So we can put that together, and again, this is just over here. That's the derivative part, and this is the other easier part to remember. And we could sum that up so you get your Taylors like this. The summation from n equals 0 to infinity of e to the 1/2 x minus 1 to the n all over 2n times n factorial. Okay? And again, this was just the general part from the Taylors, and this was your derivative at different stages. Okay, hope those help.